Hello guys, today we are going to talk about minimum subsequence in a non-increasing order. So this is a question present on lead code 1403. So the question is something like this. Input sequence is given which is not ordered, which can be which is neither in ascending nor in descending order, and we have to find a minimum subsequence out of this sequence with these conditions that given an array, obtain a subsequence of array whose sum of elements is strictly greater than sum of non-included elements in sequence. So if we see here we need to find a subsequence whose sum is greater than the elements which are not included in the subsequence. So if we see 10 and 9, their sum is 19, and rest 3 elements for 8, 4 and 3, their sum is 15, which is greater. Then again 10 and 8 is also follows the same pattern, that is it can be one of the answer, that is 10 and 8 it's 18, excluding 10 and 8 it becomes 9 plus 4 is 13 plus 6 is 16, but we will be choosing 10 and 9 out of it. So the explanation is the subsequences 10, 9 and 10, 8 are minimal such that sum of their elements is strictly greater than sum of elements not included. However, subsequence has maximum total sum of its elements. So the last condition which is given here, this condition is explained here. If there are multiple solutions, return the subsequence with minimum size, and if still exists multiple solutions, return subsequence with maximum total sum. So out of 10, 8 and 10, 9, 19 is maximum, so we will be returning 10, 9. Same as if we see this one 7, 7, 6 is the answer, because if we see 7 and 7, if we take two numbers 7 and 7, then it will make 14, while 6, 4, 4 is also 14. So we need this condition says it should be strictly greater than non-included elements, so we have to include one more element here, and for one element it's only one element. So I have created I have submitted the code. I'll just explain the logic and then you can check out my code here. So the logic is something like this. I have taken the first example. So this is a code. It's very simple, very straightforward, but why I wanted to explain is that most of people are thinking that we have to go iterate through the array in n square time, that is 2 for loops, one for loop from 0 to n last element, and the second for loop for checking the first half, and then in the second for loop only making 2 pointers, one from front and one from back. But this can be obtained using on time rather than going for a on square time. So how on time happens here is, so let's look at this code, this piece here, logic. So first the subsequence is 4, 3, 10, 9, 8. So we sort it. So after sorting we have 10, 9, 8, 4, 3. If we see any sorting algorithm, a good sorting algorithm will make it in n log n time. So let's make it. Then we have to find the sum of it. So sum will be found in O(n) time. So its sum is 34. Now in step 3, what I'm doing is I am taking sum from start. I have taken a variable SFS, and I'm taking sum from end, SFE. So how I can calculate the sum from start? At I equal to 0, the sum from start is 10, because if my pointer is at 0, there are no other elements, so sum from start is 10 only, while sum from end is 34 minus 10, because we see 34 minus 10. Then at index 1, sum from start is 19, that is 2 elements, while sum from end is 24, the sum obtained in previous step minus 9. So sum obtained in previous step was some of these elements, and now we are doing some of these 3, so it will be. Now in step 2, that is at index 2, we calculate sum of these three elements, while the sum from end, because our pointer is here at index 2, so sum from end is just of these two elements, and we can calculate it by reducing index 2 from previously obtained sum. Now the condition is our sum from front should always be greater than or equal to sum from end. So in this case, whenever we find it at the first time, that is we have found it here, we break it and we return the number of elements from the front. So this is a very simple logic here. I have just sorted it. We can also perform a stable sort. Then I have just calculated the sum. Then this variable can be ignored, but I have taken it for reading convenience, sum from front, and sum so this is sum from end and this is sum from front, and this is the simple logic which I have explained in above. I keep on pushing the element which I traverse from the front I, and whenever I find that the sum from end becomes smaller than sum from start, that is sum from front or sum from start, we break. So if I execute here, so I have taken the vector as the first one, that is 4 3 10 9. If I execute it, I get 10 9. If I run another one, so let me just do g plus plus minimum, so I get 776. If I do change to the third one, I will get 6. So this is working. I have submitted my code here. Thank you for looking at the video. Have a good day. Bye.